Okay, welcome everybody. My name is Riccardo Lippolis, and this is my colleague Jorrit van der Ven. We both work at J-Driven, a company in the Netherlands who does software for a number of big companies in the Netherlands. If you have any questions, use the Slido link here on screen. I think you're familiar with it. When we were researching Kotlin, we found out that Kotlin is actually a ketchup brand here in Poland. Has anybody have any experience with it? Is it good? Yeah. Okay, so I think we're gonna have to try and find a bottle then to bring it back.
Yeah, I actually used Google Translate, and it actually says "from hell" or something like that.
So we were a bit doubtful about it. So just a quick disclaimer: we're not Kotlin experts yet. We've been developing in Kotlin for about 6 months now, and we found that it might be a good idea to share our experiences on using Kotlin in a production environment after the first few months, to give you an idea whether or not you should do it as well. If you're in our situation, like 6 months ago, like done some workshops with Kotlin, maybe looked at some manuals and tried some experiments with it, but you don't quite know if it's a good idea to start using it actually in production, hopefully we can give you some pointers and make you embrace your inner hipster and start using Kotlin anyway. So the agenda for today, I'm going to start with a bit of context, explain our situation, the thing we're building using Kotlin. And after that, we're going to give you sort of a pros and cons evaluation of Kotlin, where we're focusing on 3 aspects. The first is the language aspects of Kotlin. Then the library and framework support, and finally also the tooling support surrounding Kotlin. And we're going to end with some lessons learned and some tips we wish we would have had 6 months ago. So as I explained, we're working at J-Driven, but currently we're working for a project for the Port of Rotterdam, one of the biggest ports in the world. It's the biggest in Europe, but not the biggest in the world anymore, unfortunately. We have a very nice view from our office, so that distracts us sometime when we're looking at sunbathing girls on the cruise ships there. They're mostly old women, so. So we work in a sort of an innovative department of the Port of Rotterdam, where we build software not only for the port itself, but also for other ports around the world, and trying to create sort of a smart, connected ports all over the world. So very innovative, very new technologies we're using. So the product we're building is basically a Skyscanner or Google Maps, but for containers. So if a shipper or forwarder wants to transport a load of containers from A to B, he can use our tool to find the most optimal route. And optimal is defined by different characteristics, such as distance, speed, CO2 emission, etc. So I'll give you a short demo just to give you an impression of our application. So this is the application we built for the port of Sohar, which is in Oman, one of the Arab Emirates. So say you want to go from Tokyo to Sohar, you're going to transport some goods. You can search, and it gives you a few different possible routes to take. And we're also building a feature where you can actually book the trip with the carriers that are supplying these trips. So you can imagine it's a pretty complex application. If you look at the stack, it's basically a React front end with some Kotlin microservices, supported with a Neo4j graph database for the heavy routing calculations. So when we started the project, we had a very tight deadline. We had to get something up and running very quickly, so we didn't have a lot of room to experiment. But at the same time, because it's the department where a lot of innovative technologies are being used, we wanted to be innovative as well. So if you look at the programming language we could use, we were given a lot of freedom in making the choice, but also they didn't want every project to have their own language, so they had just a small set of languages where we could choose from. So one of them was Kotlin, other was Scala. Well, I did some workshops and some training with Scala, so for me the choice was easy. I chose Kotlin. So, we're going to start giving you some pros and cons. I'm going to give the word to Jorrit.
Okay, thank you for the introduction. Let's start with what I think is the greatest feature in Kotlin, and that's the compile time null safety. I think everyone has ever seen a null pointer exception in its code, right? You built some application, some code, and you add all the null checks, and it's working really great. And then after a few weeks, you refactor it a bit, and something that wasn't nullable suddenly is nullable, and you change that in, you think, all the places, but then after a few weeks on production, some edge case suddenly is found, and you discover that at that certain place, you didn't change it, and then there's some kind of null pointer exception in your logs. That's pretty annoying, of course. And in Java 8, the optional was introduced to prevent this. But actually, now you had three options. Either it was null, an empty optional, or an optional with something in it. And luckily, Kotlin now has compile time null safety. So at the moment you change that parameter to be nullable, then if you forget to change that in another place in the code, you'll simply get a compiler error. So that's really cool. And if you use it in pure Kotlin code, that works great. But at the moment you start using it with your older legacy Java code, and of course you didn't add all the not null annotations, then Kotlin doesn't know if something is nullable or not. So then Kotlin assumes it's nullable, and you always have to check if the object is either null or not. So of course you can add you can see it in the code example, the double exclamation mark, which means Kotlin, I know what I'm doing, this is not null. But then if it is null, you'll still get a null pointer. Which also very nice is the data classes in Kotlin. I think everyone here has ever used something like Lombok or immutables, right? So anyone doesn't know what Lombok is? Okay, nobody, great. But Lombok is a bit annoying because it does all kind of bytecode manipulation magic. And yeah, sometimes it doesn't work, and then you have to recompile, then it suddenly does work. And well, Kotlin just has this out of the box. So if you define something like as a data class, you only have to provide the parameters. And well, it automatically creates your equals, your hash code, your toString method for you. And you don't have to maintain it yourself. So if you add something or remove something, it's automatically updated. And this works really well together with Jackson as well and Hibernate. But if you start using some other lesser used frameworks, such as Neo4j Object Graph Mapper that we were using, then you start discovering that Kotlin doesn't create any no-arg constructor, for example. So it just doesn't work with the data classes, and you have to open it and make it variable and nullable, and then basically you lose all the advantages of your data class. So yeah, it works really great if you're using Kotlin code only, but if you start working with some lesser known frameworks, then it can be quite annoying. which is also nice to mention. If you are using Hibernate and you have a lazy init collection in your data class, Kotlin will include that in your hash code. And so if you put that in a set, then it will try to calculate the hash code, fetch everything from your database. And if it is not able to do that, then you'll get all kind of crazy exceptions. So pro tip. Riccardo, you have a quiz for us.
Yeah, pop quiz. Given this piece of code, what do you think will happen here? I'll give you 3 options. So either this gives a compile error, throws a runtime exception, or it prints some string.
So who thinks A?
Yeah, show of hands.
I see a few over here, a few over there.
A, okay, and who thinks B? Almost nobody.
Nobody?
Okay. And who thinks C?
I think about half.
Okay. Yeah, about half. Okay. So, correct answer is C. And this works because of some magic called extension functions in Kotlin. So basically, the equals function or method in Java, of course, is just a normal method for you can call on an instance of an object, and if that instance is null, then it throws a null pointer exception. But in Kotlin, the equals on the string is an extension function on a nullable string. So that's pretty mind-blowing if you're coming from Java, where you're always aware that if you call a method on an object and that object is null, that it will crash. But in case of Kotlin, you can work around that by using an extension function. So in this case, you actually see a null check on the this reference, which in normal Java code, that's weird, right? But in this case, because the string is nullable, and you can see that by the question mark behind the string, the this reference can be null. So it won't throw an exception. So extension functions are pretty amazing. They can make your code more readable. Basically, what you would in Java would do with util classes and util functions. You can use the same, do the same in Kotlin, but with extension function, which makes the code more readable, because you call the function on an object, and you can chain the calls, etc. So there are a lot of useful extensions already available in the standard Kotlin library. So just a random example, the takeIf method. It's not a method implemented in file, but it's just a general extension function on an object that says, given this predicate, if the predicate is true, return the object, and if it's not, then return null. It may be confusing sometimes to see, where does this method come from? Because basically, you can define an extension function anywhere. And you can make them private, so they don't leak out to the rest of your application, but still, if it's public, sometimes you have to search where it's actually defined. But of course, the IDE helps you with that. But it can be confusing in the beginning. So a concrete example of when extension functions were very handy in our case, actually not extension function, but extension properties, which are also a thing, was in the point class in the Spring Data Neo4j library. So basically, a point is just a coordinate in a 2D coordinate system, which has an x and a y. But because we are working with geographical coordinates, of course, we had to map that to latitude and longitude. But while we were writing the code, we were constantly confused, like, was the latitude the x or the y? And that caused some very nice bugs. So we wrote the extension properties on the point class, and you can see it in the second code example, that says, okay, define a let property on the point class and refer that to x using getter. So it's immutable. And the longitude is the y. And we can just call the point.let everywhere, and we know we get the right one. So fun fact, Neo4j OGM, the object graph mapper, also has a point class. And the x and y actually reverse there, so much fun. Jorrit.
Yes, thanks. Yeah, what we also really liked of Kotlin is that the functional programming is a lot better, because in Java it was later added on. So, for example, the streams, the lambdas, they were all added later on, and they weren't a complete part of the language. So, for example, when Java 8 was released, I was super excited because finally we had these lambdas and we had these streams, and I could get rid of all the for loops and the if statements if you just wanted to filter a list. And we could use something like this, like the code example. You could just create a stream and map something and then collect something, and it's just so clean. But then after I used Kotlin for a couple of months, I looked back at this code, and I thought, whoa, this is really verbose, actually. Because in Kotlin, you can use all these operators directly on your collections. So you can just create a range between 1 and 10, then map it, and it's automatically either a list or the result of this map. So it's really easy to read, it's really compact, and you don't need any collectors or in streams or anything like that. So that's really cool. What I didn't like on Kotlin is the companion object. In Kotlin, you don't have any statics. You have a companion object, which works basically the same. But you have to put all the variables and functions in a companion block in your class. And while it is nice because you can put everything together, if you just want to add your log4j instance in your class, you have to write 2 lines extra. So, meh. Next, constructor overloading. It is a bit confusing if you're coming from Java. In Java, you just add a constructor to a class. And in Kotlin, the constructor is actually part of your class definition. And if you want to overload that, then you have to add a constructor to your class body. And also, you can't add any code to your constructor. So if you want to do some mappings or stuff like that, and it doesn't fit in the assignment, then you have to use init blocks. And, well, I'm not sure what you're thinking, but in Java, I don't think these statics init blocks were really good practice, right? But if you want to do something like that, you have to do that in Kotlin. Yeah, also, so Kotlin has a lot of really cool stuff. And in Holland, we have a famous soccer player called Johan Cruyff. And he always said, every advantage comes with its disadvantage. And Kotlin is no other, unfortunately. Because there's a lot of new cool features, but that means also a lot of new keywords that you have to learn. So the first time you want to use this method, and you're going to look up, okay, what does it do? How do I call it? You just look up the definition, and you see this, and you're like, whoa, what the hell? Inline and reified, and something with in or out, and yeah, I don't know what it is. I'll just look it up at Stack Overflow. So yeah, a lot of new keywords to learn. Yeah, so
Jorrit already mentioned the collection functions on the in the Kotlin collections compared to the Java streams. So of course, I was also very excited with the Java stream methods, you know, the map, the filter, etc. But you always have to, you know, first create a stream, then do your operations, and then map it back to a collection. So advantages of Kotlin is that all these methods are directly available on the collection. So given a collection, you can filter it, and you get a new collection directly without doing extra work. But the disadvantage is if you have a chaining of multiple operations, because every operation on the list results in a new list. So if you have this, if you use Java streams, you're familiar with it. You know, you filter, then map, and then filter again, and whatever. Every step in that chain creates a new collection. So if you want to make that lazy, Kotlin offers a thing called sequence, which is basically a lazy collection. But then again, you might recognize it. You have to first call a as sequence on a collection, then do your operations, and then ultimately convert it to something you want. Like in this case, an average, but also you have also a toList or a toSet function. So then the memories of Java streaming come back. A difference between Java Stream and the Kotlin sequence is that the Kotlin sequence can be read multiple times. But every time you iterate a sequence, all the steps in the sequence are performed again. So if they're expensive, first convert it to a list or a set, a normal collection, and then iterate multiple times. Unless you want it to evaluate again every time, of course. But another advantage of sequence over the normal collection is in this example, the second code example, you're only interested in an average age. So you don't need any intermediate collection. So in this case, because it's a sequence and it's evaluated lazy, and in the end you just ask for the average, it won't create an intermediate collection. So it performs better than when doing the same on the list. So Java streams also have the option of creating parallel streams, where you can do parallel processing on a stream. Kotlin sequence and Kotlin collections don't have that. But if you do want to perform some asynchronous operation on your collection, you have to use another technique that's available in Kotlin, and that's called coroutines. So coroutines is pretty complex as a whole. It's basically a library embedded in the Kotlin standard library, which allows you to do asynchronous programming and non-blocking stuff, but in an easier way than if you have to do all of it by yourself using threads and thread pools, etc. It's more lightweight than using threads. It sort of looks like a technique called fibers. I don't know if you're aware with that, but in Java, they're actually working on Project Loom. Don't know when it's going to be ready. It's basically a more lightweight way of doing asynchronous programming, and it looks a lot like what Kotlin is doing with coroutines. The nice thing about it is also that it integrates well with asynchronous tooling. For example, RxJava, Project Reactor, also just can convert it to completable future or the other way around. So it integrates well with existing asynchronous code. But as always with asynchronous code, it's hard to test. So just a short example of how you can do this. Say we have an expensive calculation function. You can imagine multiplying a number by 2 can be quite hard. And you want to do that asynchronously. So in the Kotlin coroutines library, there's a concept of a deferred. It's sort of like a future, but more lean. So you can have an async method in which you can add your code which you want to perform asynchronously. So we have basically wrapped an async function around the expensive calculation function. And in our main method, we call the async function, and we get a deferred integer. So that call is not blocking, and it will be executed somewhere in the future. Of course, you have some control over it, but for the sake of the demo, I won't go into that. In this demo, I'm going to block while waiting for the result, which is, of course, not the way it should be, but otherwise it wouldn't fit on one slide. And basically, in the end, you get your result, which is calculated in another thread or fiber, depending on how you want to. But basically, it could also be run on the same thread if the Kotlin coroutine code thinks that's the more efficient way of doing it. But the good thing is that you don't have to think about it. So coming back to the collections and asynchronous operations, we can modify this example to say, okay, imagine I have a lot of numbers, 1,000, and I create 1,000 deferred integers where I do the calculation. And then there is the await_all extension function. So by now you know what it is. And the await_all basically is an extension function on a collection of deferreds. And what it does is that it waits until all the calculation has been done. and then returns a collection with all the results. And then you can, for example, sum it. So pretty cool.
Yeah, so next up is the integration with the Spring framework, because that's what we're using. Yeah, well, Kotlin is just a first-class citizen in Spring. They have all annotations added to the API. So Kotlin knows if the response will be nullable or not. So you don't have all the exclamation marks. Also, they provide a plugin called the Kotlin Spring plugin for Maven or Gradle. And it automatically opens up your classes. Because in Java, a class by default is open, and you can declare it final. But in Kotlin, it's the other way around. By default, it's final. And if you want to be able to extend it later on, you have to define it as open. But of course, Spring does all its AOP magic on it. So it has to be able to extend your class or your method. And that's what the plugin does for you, so you don't have to define everything as open. And that's nice. So if I have an example like this, I don't have to add anything. The plugin will just detect this is a Spring Bean and open everything up. But if I create a bean from an external configuration, like this example, and we're using some micrometer annotation, then the plugin isn't able to detect that this is actually a Spring Bean. And you don't notice this while you're developing. You start noticing it when you start your application, and it fails miserably. And then you start debugging, and the stack traces say something about not able to extend things and to generate bytecode, blah, 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 blah. And it takes you a couple of hours to find out what was going on. The integration with Spring is really good if you know what you're doing and you know what the exceptions and limitations are. Spring also supports Kotlin from Spring Initializer, so that's really nice as well. You can just generate your project and everything is already in Kotlin.
Yeah, so one of the nice features, which doesn't necessarily give you a lot of benefit, but it's just fun to do, is that you can use sentences as function or class names. So in this example, you can see that the class name and the function name actually are a full sentence. One place where it's actually, in our case, a benefit is that you can use it to give meaningful names to your tests. So as you can see, if you run the test, you actually see a pretty good description of what the test is supposed to do, although this test isn't very useful, but you get the idea. Talking about unit tests, we are working with Mockito for our unit tests and Spring integration tests for the higher level test, and that all works pretty seamlessly with Kotlin. There's one minor issue with Mockito, and that's because Mockito, if you're familiar with it, you know that to set up expectations on your mock, you use the when function. But when is a keyword in Kotlin. So there's a way around that. You can add backticks around the when word, but of course that's ugly. So there is this plugin, again a plugin, you know, you have to use a lot of plugins, but it's called Mockito Kotlin. Yeah, very excellent, yeah, it's an excellent name. And that basically has an alias for the when method called whenever. So yeah, you just use whenever instead of when. And yeah, it's more readable. It also contains some other helpful functions to create more readable tests in a Kotlin way, but still using Mockito. So pretty nice. So talking about the IDE support, of course, Kotlin is developed by JetBrains, and JetBrains is, of course, a developer of INTELLIJ. Yeah, so if you want to play safe, just use INTELLIJ. Of course, there's also support for other IDEs. I haven't tried it, but INTELLIJ works pretty well with Kotlin. It helps you a lot in the terms of hints and warnings about pieces of code that may be written in a better way. So, given a user example again, you can see the squiggly lines indicating that this code can be a lot better. And if you read what hints is it going to give you, so for example on the if, it says, yeah, you can use a when. So listen to your IDE, look at the warnings it gives you and the hints to improve your code, and you'll see that it helps you create better readable code, and in the same way you're learning to use Kotlin in a better way. So it's not all positive. I have to say the IDE support is not fully mature yet if you compare it to developing Java application. We sometimes experience some random slowness, especially when you're doing a big refactoring on your code. The IDE can get pretty slow, and of course it makes some sense because the Kotlin is a more dynamic language. Given, for example, all the extension functions would maybe define anywhere. So, yeah, cut him some slack, right? And it's still pretty young, so give it some time. Occasionally I still get some random IDE errors. I just submit them all to JetBrains, and I don't know if they hate me for it or if they love me for it, but I do notice that they are getting less and less frequent, so I think they're working hard on it. So kudos to them for creating this plugin. So Jorrit's gonna give some other hipster features.
Let's get rid of the errors. These are some features that are nice to know, and we like them, but it's not like we have 5 minutes per feature to tell about them. But one of them is the string literal. So basically, you can add 3 double quotes, and you create a string which contains all the new lines and all the quotes within, so you don't have to escape them. And especially if you're writing unit tests or integration tests and you want to add little pieces of JSON to your test, then this is really useful because you don't have to escape it or replace characters. I think we're also using them for JQL queries in the annotations in Spring Data, so it makes it just a lot more readable. Auto-casting is also incredibly nice. If you used it for a while, you just forget that it wasn't like this in Java. But what Kotlin does is it detects that something must be of some type, and it automatically casts it for you. So in the code example, Kotlin sees, okay, this must be a double, because in the when statement it says is double. So it automatically casts your object to a double. And this also works for example, if the number would be an object, and I'd say is number, then it would cast it to only the number. So that's also really nice. It saves you a lot of inline casting. And of course, the default method parameters, which saves you overloading methods. So if you have a method, you want to add something, you don't have to add another method to overload it. You can just add the parameter and supply a default value. And together with the named parameters in Java or in Kotlin, this is really useful because it just saves a lot of code, as you can see in the example. Destructuring variables is also really handy. If you get a return value and it's an object and you just want to have a few values out of it, not everything, you can destructure it into a couple of variables and you can use it directly. And this doesn't only work with objects, but also with pairs, for example, and lists. So you can destructure a list with 10 values into 10 variables at once. And it's really useful in sequences and lists and stuff like that. And last but not least, the if, try, and when in Kotlin are expressions. So they can return values, and you can assign those values to a variable. So for example, a try-catch statement, you can just return a value and assign that right away. Or an if statement can just be written inline. So instead of your ternary operation, you can just write an if statement. And I think this is pretty readable. I'm not sure what you think. You like this? No? Oh, too bad. Then stick with Java. And of course, operator overloading. Probably Scala developers are going to love this. You can just overload, for example, the plus operator to combine lists or to add values to a list. So you can just have two lists, plus, and they're together. Or if you add, in this case, what was it? They were integers. I can just say result plus, for example, 5. And then the number 5 is added to the result. And you can also overload them yourself, because this is by default, but you can also add your own overloads, and you can build basically your own DSLs and stuff like that. It's nice. So, our lessons learned.
Yes. So our main experience is like, we don't want to go back to Java. We originally did a Java workshop where we were basically figuring out the new features in the new Java, Java 12, 11, etc. And we were actually pretty bummed that we had to write Java code again instead of Kotlin, because we forgot the semicolon, and there were all these verbose statements, and we were very lucky that we're using Kotlin. So we wouldn't want to go back, despite of the disadvantages we told you. So in essence, it's easy to start with Kotlin, because the IDE, especially INTELLIJ, helps you a lot to convert your existing Java code to Kotlin. It isn't always the best conversion, but it gets pretty close. But what I do want to give you is that it's strongly recommended to have some experience with functional programming languages. I did a course on Coursera called Functional Programming Principles in Scala. And most of the time I didn't even know what he was talking about, but in essence I got a general idea of what functional programming is. And that helped me a lot in understanding what Kotlin is trying to achieve. To get the most benefit out of using Kotlin. So it's pretty obvious, of course, but start small, start with a hobby project. Don't immediately just convert your entire enterprise application to Kotlin, but for example, you can start by just using Kotlin data classes to reduce the amount of boilerplate code, and to get acquainted with familiarized with the Kotlin syntax. If you're haven't done any Kotlin exercises yet, or if you just want to get more familiar with the Kotlin language, I recommend the EDUTOOLS plugin in INTELLIJ. Basically, it gives you some cones, some assignments, pretty short assignments to familiarize yourself with the Kotlin syntax and all the cool things it has. So, highly recommend. So, thank you. We're going to look at the questions now, if there are any.
I certainly hope so.
Yes. Okay.
Now we just have to put them on the monitor.
Yeah. Just a minute.
There it is.
Okay, so
maybe it's easier to read them from there.
First question: how does Kotlin compare to Groovy in terms of performance? We're not Groovy users, so basically, I wouldn't dare to mention anything about that.
Maybe the only thing we can say about it is that we're using Gradle with the Kotlin DSL. And we noticed that the Kotlin DSL is significantly slower than the Groovy DSL.
Yes.
So I hope that's not an example to how Groovy and Kotlin compare to each other. But in Gradle it's a bit slower.
Yes. Let's see. Okay. So the second question, Java streams are lazy and don't create temp objects even in long chains. What about Kotlin chain calls? Okay, so that depends whether or not you're using sequences or whether you're performing these operations on collections. So if you do it on collections, every intermediate step creates the complete new collection resulting from that operation. So basically, in Java streams, you can have an infinite stream. You can't do that with a Kotlin collection, but you can do that with a Kotlin sequence, because the sequence is only evaluated in the last step when you iterate over it. So when you convert it to a list, or when you just use a for loop to iterate it, or whatever. So yeah, but Java streams and Kotlin sequences are comparable in that sense. But yeah, Kotlin collections do create intermediate objects.
Yeah, and your IDE will warn you for that. So if you're using a really long list of commands on, for example, a collection, it will warn you from, yo, this is very slow, just convert it to a sequence.
Yes. Next question. Is there Java to Kotlin transform of code, such as in Android Studio? And
yes,
if not, have you tried to migrate of non-Android project in Android Studio? So we're not using Android Studio, but basically, yeah, it has a lot of similarities with INTELLIJ. If you paste Java code in a Kotlin file, INTELLIJ will convert it to Kotlin code for you. It works pretty well. After the conversion, INTELLIJ gives you warnings and hints how it can be even better. So I don't understand why they didn't just do that immediately. But no, the code it's pretty well for an initial version. Yeah, so probably that works also in Android Studio.
Yeah, I guess so. Yeah. Basically the same application, right?
Yeah. Next question, is map method lazily evaluated like it is in JavaStream? Well, yeah, mentioned it earlier, but yeah, in the sequence map, so if you call map on a sequence, that lazily evaluated. If you call map on a collection, you get a new collection instantaneously. Did you consider Groovy with @compile static for your projects? No, we didn't consider Groovy. We found Kotlin to be more hip.
Okay.
Yeah, @compile static, no experience with that.
Yeah. So are there any Java 5 to Kotlin conversion plugins for NetBeans? Really? I wouldn't know. We are using INTELLIJ and we like that. I think because of the laughter I hear, there isn't anything like that. Sorry.
First convert your code to at least Java 8 before you start considering that. Is Kotlin the best language on the JVM? Yeah, for me it is. But yeah, I have to say I haven't tried all the languages on the JVM, so I'm a bit biased. But yeah, I love working with it, and yeah, it shows a lot of potential. Of course, it still has some work, but yeah, what project doesn't, right?
So I guess that's it.
Yeah, thank you for your attention. If you have any additional questions, just come up to us, and we'll be happy to answer it. So thanks for listening.
Thank you.